Hello, welcome back to our little corner on the web, where we hope to develop and nurture a love for math. Today, we'll go over some of the one problem from the 27th PMO qualifying stage. We'll start with part 3, question 8, or the last problem in that set. Okay, so I'm flashing the problem here first for those of you who wanted to give it a try. Part 3, question 8, typically that's the last, so that's the hardest problem supposedly for each step. Here, the problem states, for a positive integer n, we define the function s sub 26 of n to be the sum of the 26th powers of all the positive proper divisors of n. So the expression is written differently here. That is, what s sub 26 of n is. For how many integers 2 less than or equal to n less than or equal to 100 is s sub 26 of n odd? Okay, so you may pause here just to see if you want to give it a try before diving in. Okay, so first thing I want to say about this problem, usually when you're this deep into the PMO set, things might get confusing. The real lesson here in this problem is don't get scared by the wording. We will spend more time actually trying to analyze the wording than the proper solution. You'll see that the proper solution actually is fairly simple. Okay, so here, let's look at what it's saying, right? It's saying that the function s sub 26 of n is basically a sum of a few things. So let's try it out. S sub 26 of, let's say, 6, right? Well, it's supposedly the sum of the 26 powers of all the positive proper divisors. So 6, the proper divisors of 6 are 1, 2, and 3. Basically, all the factors except 6. So we can write s sub 26 of 6 no more than 1 squared plus 2 squared plus 3 squared. Okay. Same thing, for example, s sub 26 of 10, right? 10's proper divisors are no more than 1, 2, and 5. So this will be 1 squared plus 2 squared plus 5 squared. I'm sorry, not squared. All of them to the 26th power. Sorry. Okay. Okay. And we could test out a different number. Let's say s sub 26 of 11. Well, it turns out that the proper divisor of 11 is fairly simple. It's just 1. Okay, so this is just 1 to the 26. Okay, and we're asked for how many integers between 2 through 26, through 100 inclusive, is this function odd? Okay, well, let's look. For the function to be odd, then there has to be an odd number of proper factors or proper divisors of n. Okay, meaning a number like 54, okay, will not have an odd proper divisor because this will be 1, 3, 9, 27, 2 to match a 27, sorry, and then 54. Okay, so here there's 3 of them. And again, if you take an odd number to the 26th power, it's still going to be odd. If you take an even number to the 26th power, it will still be even. So the only way we get an odd sum is there's an odd number of odd proper divisors. Okay, so actually, if you just apply that logic, that it's only when there's an odd number of odd proper divisors, then the question becomes easy. We can actually even rephrase the question. Okay, if we rephrase this whole question differently to say, how many integers n from 2 to 100 inclusive, and then have an odd number of odd proper divisors, then this question actually is the same as this question. Okay. So this one, some of you learned proper divisors maybe way early in primary school or early junior high. You can even list it down, but hopefully we'll do something, way faster, right? At least for some cases. So notice a while ago we did S sub 26 of 11, and we found that the only proper divisor of 11 was 1. So 1 to the 26. And that's obviously 1, and that's obviously odd. It turns out that all primes are like that. So case 1 immediately is all primes below less than 100. And some of you might just remember this. There are 25 of them. Okay. And there's another special case, case 2, which is powers of 2. Powers of 2 will only have 1 and every other factor being even. So the ones that are not included in case 1 here will be from the set 4, 8, 16, 32, and 64. Okay, so there's 5 of those. Okay. Then we will just begin to construct a few cases. There's only actually 3 more general cases. Case 3, where the 2 lowest factors are 1 and 3. Okay, 1 and 3. And we will add another odd factor, progressively going higher. So if we add 5 as the next factor, then the numbers 15, 30, and 60 satisfy. Note that 45 is not in this list because we add 45, we introduce a 9. Okay. And then, so we can just go on. 137 gives us 21, 42, 84. 139, we have to be a little careful here. 9 is 3 squared. So 9 doesn't satisfy because 9 is not a proper divisor of 9. So here we only have 27. Okay. You might ask, why not multiply it by 2 and get 54? Well, if we get 54, then 27 gets introduced as a factor. Okay. Then the next one is 1, 3, 11. Again, just progressively getting higher on the third divisor. We get 33 and 66. Again, be careful not to include 99 because you then introduce 9 as a factor. And then 1, 3, 13. You get 39, 78, and then you get 1, 3, 17. Okay, 1, 3, 17, which gives us 51. 1, 3, 19, which gives us 57. 1, 3, 23 is the next prime, which gives us 69. 1, 3, 29 is the next prime, 80, which gives us 87. 1, 3, 31, which gives us 93. These are all the ones that satisfy where the 2 lowest odd divisors are 1 and 3. Okay, if we count all of these, there will be 9, 10, 11, 12, 13, 14, 15, 16 of these. So now we have, I'm going to list it up top. We have 25 from the primes, plus 5 from the powers of 2, plus 16 from the ones that are 1 and 3. Okay, so now we'll do 1 and 5s. So 1, 5, 7 gives us 35 and 70. 1, 5, 11. The next prime basically gives us 55. 1, 5, 13 gives us 65. Okay, 1, 5, 17 gives us 85. 1, 5, 19 gives us, okay, sorry, 1, 5, yeah, gives us 95. And again, as we did in the previous one where we included the square, we can also include the square, or we should include the square, 1, 5, 25, but this one doesn't give us 25, this one gives us 50. Okay, because 25 is not a proper divisor of 25, but multiplying it by 2 makes 25 a proper divisor without introducing any other odd factors. Okay, so this one is 2, 3, 4, 5, 6. Wait, did I miss one? Oh, 50 and 100. Sorry, almost. Okay, I knew there should be 8 here. So this is total of 8. Okay, so we add another 8. And then we're only left with one more general case, which is 1 and 7. Okay, 1 comma 7 comma 11, which gives us 77. And then 1, 7, 13, which gives us 91. And lastly, the square. The easy ones to forget here are probably the square. 1, 7, and 49, which again, similar to the 1, 5, 25, gives us 98. Okay, so there's a plus 3. Okay, so this is 46 plus 11. So that's where we get 57. Okay, so the final answer here is 57. So as I said, the lesson I think for this question really is not to get scared or thrown off by the wording. The wording is designed really to weed out, I guess, the people who don't want to spend time and energy trying to understand, because the notations do look pretty scary to most people. Okay, so hopefully this solution was educational and helpful to you. If it is, do hit the like button and subscribe. Thank you for watching.